So we are going to begin doing some algebra that we have looked at a little bit in our morning work, but we really want to now focus on how to write some math problems that contain variables, and then to understand what they're actually asking of us. So before we begin, we need to define two terms that we're going to be using today. We need to know what a variable is, and we need to understand what an expression is. So you can look both of these up in Google or on a dictionary app, but we're going to go over those together. So a variable is any unknown value that we're going to represent with a letter. So it's important to know that we use lowercase letters when we're doing our variable representation. And I also like to stick with letters that don't look too close to numbers when I'm writing my variables. So I don't use the letter L very often. I also don't use the letter X very often because it looks like the times sign. And then the letter S can sometimes look like a 5. So just be very careful as you're making your choices for variables that you are making sure everything looks like a letter when it's supposed to be a letter, and it looks like a number when it's supposed to be a number. All right, we're going to talk about what an expression is, and we've seen expressions. It just may not be a word you've used to describe them. An expression is any number sentence that we use in math and it has to have a couple characteristics. It has to have at least two numbers. They could actually be variables as well. And at least one operation. So it's going to be a math problem that does not have an official solution. And it's going to contain at least two numbers, and those numbers could be actual numbers or unknown numbers, variables. And it must have at least one math operation, which means it must have at least add or subtract or multiply or divide. And that would make an expression. The difference between an expression and an equation is an equation has an equal sign and a solution on the other side of the equal sign. So when we see just the problem itself without the equal sign, it is called an expression. And when we add an equal sign and a solution, it becomes an equation. All right, so when we're doing math problems that we want to understand what they're asking of us to do, there are words that are good clues as to what kind of math we're doing, what operation we're doing. And a lot of these words are words that we've done before. You've looked for them when you've done story problems. So a lot of these you're going to be familiar with. So words that I can use to identify addition. One of the most obvious is add. It's a word we see a lot. We'll say, for or added to, 4 added to 5. We might see words like all together. So you might have a question like, how many do I have all together? We have the word that means the solution to a math problem. So we have sum. We might see something like increase or increased. We might see words like and. I have 4 of this and 2 of that. Combined and total. Of course, there are more, but this is just a good list to get us started. Subtraction, I might see words like minus, decrease, difference, less, or takeaway. Multiplication words, a common one we see is times. How many times does something happen? I might have product multiplied by there are also words that mean multiplied by a specific amount. So for example, doubled, which means times 2, or triple, which means times 3. And there are more. You could have quadrupled, which is times 4, but we're just gonna give those two as an example. Division has its own words as well. We might use the word divide or divided by. We might talk about making groups, or we might use the math word quotient to describe a division problem. All right, so we're going to use what we've learned up there and those clue words to help us identify some math word expressions and what they would look like written as number sentences. So the first thing we need to remember is that any unknown quantity we're going to represent with a letter. So when I look over here and I talk about having a number of socks divided into pairs, and we know that a pair is a group of 2, I have to figure out what is the thing I don't know, and that is right here, a number of socks. I don't know what that number is. It just means I have a bunch of them. And when I divide them into pairs, that's putting them into groups of 2. I see the word divided into or divided, which tells me it's a division problem. So I'm going to turn that word expression into a number sentence. So I have an unknown number of socks, N, and I'm going to divide that pile of socks into pairs. So N divided by 2. In algebra, that can also be written as a fraction, N over 2. And those mean the same thing. My next one, I'm going to look for my unknown. So I have that here, the product of 9 and a number. A number is my variable. It's my unknown amount. And I see the word product. Product is a word we're going to use for multiplication. So I have the product of 9 and a number. And in algebra, multiplication has an interesting pattern of being written. When we write a number directly next to a variable, we always put the number first, and then we put the variable right next to it. So we might have 9n, even if in the story problem, the variable comes first, because we know that we can multiply our numbers in any order according to the commutative property of multiplication. So it doesn't matter if we write the 9 first or the number first or the variable first, But the pattern that you're going to see in algebra is that you have the 9 next to the lowercase number. Sometimes you will also see the numbers in parentheses, but that's more often seen when both numbers being multiplied together are an actual number, not a number and a variable. All right, so the next one, a number increased by 12. So I've got my clue word there, increase, and that is an addition clue word. So I'm going to say that I have my unknown quantity, a number, increased by 12. So n plus 12. Subtraction is our last one. Less than is my clue word. A number is my variable. But subtraction can be kind of tricky because we do not have the option of using the commutative property to do a subtraction problem. So we have to really listen to the wording of the problem and figure out what are they asking of us. So in this case, I'm saying I have 4 less than a number. So in my head, when I think about that, I'm saying I have this number that I started with, and then I'm going to have 4 less than that. And I want my final answer to be 4 less than that number. So I'm going to start with my variable, and I'm going to subtract my 4, because this is the quantity I start with, and I want 4 less than that. And in order to get 4 less than a number, I'm going to have to take 4 away from the amount I start with. If it was worded the opposite way, a number less than 4, it would be written the other way with 4 first and then taking away the variable. All right, we're going to move over to the other side, and we're going to actually now do the opposite. We're going to start with an expression, and we're going to turn it into words. And this can be really straightforward. We don't need to get super creative unless you want to. We can just read what's written there and then turn those into word phrases. So if I start with my variable n, I might say, well, we're going to call that a number. And then it's a plus sign. So I might say a number, and I could pick one of my my addition words that makes sense. So I might say increased by, or added to, or the sum of. So I'm going to say a number, and I'm just going to use and. That's a good one. A number and then the number written there is 6. So a number and 6. And when I put those together, I would have my solution. H, and then the minus sign 9, so we're looking at subtraction, and I can just be pretty straightforward with this one. I can say a number minus 9. I don't need to be creative with my wording on this unless I want to be. I could say a number take away 9, or a number decreased by 9. Those would also be options. All right, we learned over here that multiplication is when a number and a letter are side by side with no symbol in between them. So this means 4 times r, and I could write that in a straightforward way, 4 times a number. Or I could be a little bit creative and say 4 multiplied by a number. I could say a number quadrupled, which would be, we learned that quadrupled means times 4. Those would be other ways I could write that expression. And my last one, 15 divided by a number. Again, I can be pretty straightforward on that and take my number and say divided by my variable. I could say 15 broken into an unknown number of groups. That would be another way to say it. Or the quotient of 15 and a number. Those would also be options. All right, so at the bottom of your paper, you have 4 expressions, 2 written as words, 2 written as numbers, and I want you to write them on your own the other way. So if they're words starting as words, I want you to write them as number sentences. If they're starting as number sentences, I want you to write them in words. And you can check back at the end of this video for the answers to those. All right, here are the answers to the exit slips. Check your work and see how you did, and then look for the assignment given to you by your teacher.